Well, we're looking at this next video of solving for angles in a right triangle. This is the third video in a three-part series. This is the last part. So if we want to go ahead and get started with this, in the previous two videos we talked about, video one talked about the formulas, the labeling sides of the triangle. Part two talked about finding missing side lengths. If you're given an angle and one side length, you could find the other two missing side lengths using sine, cosine, or tangent. And then this video talks about finding two angles. If you're given two side lengths, you can find the angles of the triangle from that. So the steps for solving a right triangle for missing angles. You notice these steps, for the most part, look the same. I've highlighted in green which parts are a little bit different. Step one says label the hypotenuse. Same step as before. Step two says identify the unknown angle. And in this case, it's an unknown angle because in the previous part two of the video, we knew one of the angles. In this situation, we're not going to know any of the angles other than the right angle. Step three says label the opposite side and the adjacent side. That's the same as before. Step four, determine whether we're using sine, cosine, or tangent. And step five, substitute the values into the trig ratio of sine, cosine, and tangent and solve. And that's going to give us one angle measurement. So if we have the right angle and we also just calculated one angle measurement in step five, then we're going to use the triangle sum theorem to calculate the other two. Or I'm sorry, not the other two, the other angle, the third angle. So let's go ahead and move on and go ahead and do some of these. This says solve the triangle, find all side lengths and all angle measures. Okay, find all side lengths and all angle measures. Well, let's find the angle measures first. We know we have two side lengths, so as before, if we have two values that we know, we can always find the third value. So let's go ahead and label a hypotenuse. Hypotenuse. Step two says determine which unknown angle we want to solve for, and it doesn't matter whether you want to solve for x or y. I'm going to pick y. So in this case, theta is equal to y degrees. So now from y, let's label the opposite and adjacent sides. 7 is the opposite side and a is the adjacent side. Well, let's go ahead and look at our problem here. We know the opposite is equal to 7. We know the hypotenuse is equal to 25. So if we look, which trig function will we be using to solve this? Sine, cosine, or tangent? Well, it says opposite and hypotenuse. Opposite and hypotenuse, it's probably going to be sine because cosine needs the adjacent, and so does tangent. So sine is the trig function we're going to be using. The formula says we take sine of theta, and in this case, theta is y. So we say sine of y is equal to opposite over hypotenuse. Opposite is 7, hypotenuse is 25. So from here, we need to do some calculations. I am running out of room, so let me see if I can get some room down here. All right, so this is where we're going to do our work at down here. So sine of y is equal to 7 over 25. Now we need to calculate, we need to get y by itself. Well, a lot of you might think that it's a multiplication sign right here between sine and y, and that is not the case. Okay, it is not sine times y. Sine always has to have a value with it. and the value with it now is y. So we have to figure out how to get rid of sine. Well, the opposite of taking the sine of something is taking the sine inverse. The sine inverse. And sine inverse is spelled, or is written like this, sine inverse, okay? And when you abbreviate it, like I just did in that math problem, it is sine, and then you have a -1 exponent with it. And so basically, when you do the sine inverse of sine, it cancels out, it leaves you with y. So remember, if you take the sine inverse of the left side of the equation, you have to take the sine inverse of the right side of the equation and sine inverse. I don't like that. I'm going to write it down here. Y is equal to sine inverse of 7/25. And see, we kind of did squeeze it in there. There's no room to squeeze it in there, so I just rewrote it down here for you. So y is equal to the sine inverse of 7/25. Now, if you look in your calculator, if you look above the sine button, you should see the sine inverse button. And you're probably going to have to press second and then sine to get to sine inverse. And all you do is you remember, if you are using a graphing calculator, you may need to make sure that your mode is set to degrees because we're working in degrees here. So we're going to say sine inverse of 7/25, and that gives us y is equal to 16.3 degrees. Y is equal to 16.3 degrees. Okay, I'm going to erase some of this work here. Okie dokie. So, since we know that we have a 90-degree angle here, since this is 90-degree angles, these two angles must add up to equal 90 degrees themselves. So therefore, x will equal to 90 minus 16.3 degrees, and x is equal to 73.7 degrees. So x is equal to 73.7 degrees. That's how you calculate the third angle. And calculating the third side, side A down here, is fairly easy because if we have a right triangle, we have two of the sides, and we are trying to find the third side. We just go ahead and use Pythagorean theorem. So we have a squared plus 49 is equal to 625. And you need to get a by itself. So you subtract 49 from both sides, and a squared is 576. And the opposite of squaring something is the square root of it. So a is equal to the square root of 576, which is 24. A is equal to 24. So we have all angles and all side measurements here. So this right triangle is solved. If you did notice that the side measurements are 7, 24, and 25. That would be a Pythagorean triple. If you have those memorized, that makes calculating some of these a little bit quicker. Okay, if we look here, it says solve the triangle, find all side lengths and angle measures. Well, let's go ahead and find the, do you want to find M or N first? Well, we know that since both sides are 12, those sides are congruent, so therefore M and N are congruent. They are the base angles of an isosceles triangle, so therefore they must be congruent. So let's solve for M. Let's solve for M. First off, identify the hypotenuse. The hypotenuse is X. Opposite side is this 12. And the adjacent side is this 12. Okay, so from here, we know that theta will be equal to M. We know that the adjacent side is equal to 12, and the opposite side is also equal to 12. So which trig function will we be using? Sine, cosine, or tangent? Well, let's go back here and look. Adjacent and opposite. Which trig function uses adjacent and opposite? Not sine and not cosine. Adjacent, opposite. Tangent is the trig function we will be using. So, tangent of theta. Theta is M. Tangent of theta is equal to opposite, which is 12, over the adjacent, which is also 12. Now we know that in order to get M by itself, the opposite of tangent is tangent inverse. Those cancel, and if we took tangent inverse of the left side, we also have to take tangent inverse of the right side. And I reduced 12 over 12. 12 over 12 reduced to 1. It's going to be less buttons you have to type into the calculator. If you can do that reduction fairly quickly, go ahead and do that. I don't believe this one's going to be hard. If you type that in your calculator, you should be getting the tangent inverse of 1 is 45 degrees. Which makes sense because if you have an isosceles triangle, one angle is 90 degrees. The other two angles, the other two base angles must be congruent. So therefore they must both add up to equal 90. And if they're congruent, they're both 45 degrees. And the base angles there are only congruent because it's an isosceles triangle. Okay. So we know two sides. We know all three angles, so now we just need to calculate this last side, the hypotenuse. And plug that into your Pythagorean theorem. 12 squared plus 12 squared is equal to x squared. We know both of these are 144, and that's equal to x squared. So we know 144 plus 144 is 288. And we have to get x by itself, so we will take the square root of both sides. So x is equal to the square root of 288. Since it's the hypotenuse, we know that it should be larger than 12. And it is 16.97. 16.97 is is a fairly accurate answer. So now we know all three sides and all three angles. You go ahead and see if you can calculate this one on your own. See if you can calculate x and y. Let me trace over top of those. You go ahead and try and solve this out, and then I will work it out fairly quickly and give you answers, and you can check my answers with your answers. So go ahead and pause the video and then try it. All right, first off, identify the hypotenuse. Second step, identify the angle that we are going to calculate. Letter x. So theta is equal to x degrees. So we're going to calculate x. So from x, 30 is opposite, r is adjacent, and so we know opposite is equal to 30, hypotenuse is equal to 35, and we're using those two numbers. We're not going to use r because we don't know what r is equal to. If we were going to say the adjacent was r and we wanted to use these two and plus try to find x, well, here's one unknown and here's the second unknown. So you can't solve an equation when you have two unknowns at the present moment. So let's go ahead and get our work back up here. And I know opposite and hypotenuse. Sine uses opposite and hypotenuse. So sine of x is equal to opposite over hypotenuse, which is 30 over 35. In order to get x by itself, take the sine inverse. So x is equal to sine inverse of both sides. 30 over 35. If you wanted, you could have reduced that by 5 and gotten 6 over 7. So x degrees is equal to sine inverse of 30 over 35. So when you go ahead and type that in your calculator, you should be getting something like 59.0 degrees. It was 58.997. I just rounded that up to 59.0. Okay. So now if x is equal to 59.0 degrees, we know y is going to be equal to 90 minus 59 should be 31. 31.0 degrees. And find the third side. R squared plus 30 squared is equal to 35 squared. When you work that out, 35 squared is 1,225. 30 squared should be 900. And we have r squared. Subtract 900 from both sides. So r squared is equal to 325. Square root of both of these, and that leaves r is equal to 18.03. And I guess we probably should be using the approximately symbol here since we are rounding. You rounded, you could use the approximate symbol. Okay, we know all three side lengths, we know all three angles. The triangle is solved. One more. Go ahead and try this one on your own. I will work this one out quickly, and you can see if your answers match mine. Go ahead and pause the video. Label the hypotenuse. Here's the hypotenuse. Let's solve for y. So 14 is opposite. 8 is adjacent. You could have solved for z, and you still would have gotten the same answer. All right, so if we know the opposite and the adjacent, I believe tangent uses opposite and adjacent. And since we're finding theta to be equal to y, so tangent of theta, or tangent of y, is equal to opposite over adjacent. You have to take tangent inverse to solve here. So the tangent inverse cancels out tangent, and we're left with y is equal to tangent inverse 14 over 8, or 7 over 4 if you reduced. And so you need to use that here. Tangent inverse of 14 over 8 is equal to 60.26 degrees. We rounded, so it was approximately equal to that. And we're looking for z, so z degrees is equal to 90 minus 60.26. And z should be 29.74 degrees. So we know both angles and the right angle, so we know all three angles. We know two sides, so now we need to calculate the third side. So let me go ahead and do some work here. Oh, the hypotenuse is x squared, so we say 8 squared plus 14 squared is equal to x squared. Eight squared is 64, 14 squared is 196. 64 plus 196 should give you 260. And in order to get x by itself, you have to take the square root of both sides. So x is equal to the square root of 260 is equal to 16.12. And you notice this is 16.12, and it is the longest side. 8 and 14 is shorter than 16, so the hypotenuse should always be the longest side in a right triangle. You need to just kind of use that thought process to just kind of think about that every time you solve it, and that kind of helps you, let you know whether you got the right answer or not. That's one step into checking your work. Because we know if we got, in this problem, if we got x was equal to 10, we know we would have gotten the wrong answer because 10 is less than 14 there. So in this last example here, it says use the given information to find the angle measures of the rhombus. Use the given information to find the angle measures of the rhombus. So we know that there's lots of things we know about a rhombus. We know rhombus is a parallelogram, and but the diagonals of a rhombus are perpendicular. Okay, so they're perpendicular. So therefore, this makes a right triangle. Makes a right triangle. So we know two of the sides. We can find this angle here. That angle is the angle we need to find. We cannot find this whole angle here, because if we wanted to find this whole angle here, we'd have to have a right triangle, and this is not a right triangle. So we can't calculate that at the present moment. But we can calculate theta. And if we know what theta is, we should be able to say that, well, let's go back to our properties of what we know about a parallelogram. We know the diagonals bisect each other. So therefore, if this is 6, this one must also be 6. And if we have a right angle here, this must also be a right angle. So now we have side, angle, side. So we know that that triangle is congruent to side, angle, side. That triangle there. So those two triangles are congruent. And since those two triangles are congruent, theta and theta are also congruent. Corresponding parts of congruent triangles are congruent. So what we have to do is calculate 1 theta and then multiply it by 2 to get that whole angle there, because we need to find the angle not angles, find the angle measurements of the rhombus. And if we find one of those thetas, we multiply it by 2, and it gives us that green angle that I just put in there. Okay, so let's go ahead and calculate one of those thetas. Let's use this one. So here's the hypotenuse, 6 is the opposite, and 8 is the adjacent. So opposite and adjacent is tangent. Tangent of theta is equal to opposite over adjacent. Getting ahead of myself. If theta is the unknown, we need to get it by itself. So we say tangent inverse. And so therefore, those cancel. So theta is equal to, and if we took tangent inverse of the left side, we have to take tangent inverse of the right side. And theta is equal to tangent inverse of 6 over 8. You could have written 3 over 4 in there. And you should get theta is equal to 36.87 degrees. Theta is equal to 36.87 degrees. And remember, I said we had to multiply that by 2, because, let me clear some of this out. So since theta is equal to 36.87 degrees, this theta is also equal to 36.87 degrees. And remember, they were corresponding parts of congruent triangles. And so therefore, altogether, let's go ahead and label this A, B, C, and D. So multiplying by 2, so angle A, B, C. The measurement of angle ABC is equal to 36.87 times 2. 73.74 degrees. So there we have one angle. It's asking for angle measurement, so we need all 4 angles. So since this rhombus is a parallelogram, we know that the opposite angles are congruent. So the measurement of angle ADC is also equal to 73.74 degrees. And since it is a parallelogram, we know opposite sides are parallel. So if we have parallel lines cut by the transversal AB, we know that same side interior angles are supplementary. So the measure of angle ABC plus the measure of angle BAD are same side interior angles, and so they must be supplementary. We've already calculated ABC to be 73.74. And so in order to get the measure of angle BAD by itself, we have to subtract 73.74 from both sides. And when you take 180 degrees and you minus 73.74, you're going to get 106.26 degrees, and that is this angle here, BAD. And so therefore, if we have BAD, its opposite angle, DCB, is also congruent. So the measure of angle DCB is equal to the measure of angle BAD, which both of them are 106.26 degrees. So this is one way that you can use trigonometry to solve for angles and side lengths of a rhombus or parallelograms in which the diagonals bisect each other, or quadrilaterals. Just really anytime you have right triangle, you can use right triangle trigonometry. So this is all we have for this video of finding missing angle measurements. So if you have any questions, just let me know. We'll try and get those cleared up for you. Appreciate you listening. Thank you very much.